Hello and welcome to EC Electronics. So in today's video, we'll be discussing about binary symmetric channel and binary erasure channel. This video is a quick revision of the binary symmetric and binary erasure channels. We'll be seeing the channel diagrams, the channel capacity, equations, and also we'll be seeing the channel matrix. And also towards the end of this video, we'll be doing some numerical questions also connecting to the binary symmetric and binary erasure channels. Okay, so this video is very useful if you're preparing for any GATE exams or ISRO exams. Okay, so let's see what is binary symmetric channel and binary erasure channel. Today's video we are going to see about binary symmetric channel, that is BSC, and binary erasure channel. These are two channel models which is used in digital communication or information theory. Okay, so in the case of a binary symmetric channel, the BSC or binary symmetric channel is a common communication channel model used in coding theory. This is actually a special case of discrete memoryless channel. So this is a small representation, that is the representation of a BSC. Here the channel has two input symbols and two output symbols. Okay, you can see it clearly that the channel is having two input symbols here. These are the two input symbols, these are the two output symbols. X0 and X1 are input symbols, Y0 and Y1 are output symbols. Okay, so the channel is binary symmetric channel. Now, why it is called as symmetric? Because the probability of receiving a 1 if 0 is sent, and also the probability of receiving a 0 if 1 is sent. That is, here if you see, you are sending a 1 and you are receiving a 0. And here you are sending a 0 and you are receiving a 1. So these two probabilities are equal. And also this probability, the probability of sending a 1, receiving a 1, probability of sending a 0 and receiving a 0, again they are also same. So this similarity makes it a symmetric channel. Okay, so that's why it is called a binary symmetric channel. Okay, so this is the structure of a binary symmetric channel, and the probability P we have written in the branches. There is P here, there is 1 minus P. We know that the total probability is 1. So if this is P, then this is 1 minus P. And this probability P is called crossover probability. And the range of P lies in between 0 to 1 by 2. Maximum value of P is 1 by 2, and this value we take for calculating the channel capacity. In order to calculate the channel capacity equation, we take P or the crossover probability to be 1 by 2. Okay, so this is the simple introduction to binary symmetric channel. Now let's see what is the probability matrix of a binary symmetric channel. So from this diagram we can write the matrix. This is a probability matrix or channel matrix of a BSC. So when sending a S X0, what is the probability of receiving a Y0? So here it is, X0 is sent, Y0 is received, probability is 1 minus P. So it is here. Then when we are sending X0, what is our probability of receiving Y1? This is the probability and it is P. Similarly, probability of receiving probability of receiving Y0 while sending X1 is P, and receiving Y1 while X1 is sent is 1 minus P. So this is the probability which is written in the branches of the channel diagram. Okay, so this constitutes a channel matrix or a channel probability matrix, and which is represented by P of Y by X, receiving of, this is a conditional probability, right? Probability of receiving of Y when X is sent. Okay, so that is the channel matrix. Now let's see what is the capacity of a binary symmetric channel. Next, we are going to see the channel capacity for a binary symmetric channel. We know that channel capacity is the maximum information of I of xy. There are two symbols x and y. So that is x0, x1 and y0, y1. So maximum of I of xy is the channel capacity. Also, as I've told in the beginning, we'll be taking the probability P of x0 equal to P of x1 equal to 1 by 2. And also we know that from the diagram, P of x1 by x0 equal to P. That is, probability of receiving y1 while sending x0 is P, and probability of receiving y0 while x0 is sent is 1 minus P. Now the equation of I of xy we have discussed in the initial videos, the equation for information, j equal to 0 to capital J minus 1, k equal to 0 to capital K minus 1, p of xj yk log 2 p of yk by xj by p of yk, and here again we'll put j equal to k equal to 2. We know that there are two symbols for x0 and x1, and for y there are the y0 and y1. So j equal to k equal to 2, and again we'll substitute px0 equal to px1 equal to 1 by 2 in this equation, and while solving, this is a lengthy derivation. I don't think you require it for your competitive examination, or for your semester exams also. Sometimes only this will be asking. So the end equation is the most important one. C equal to 1 minus HBP, where C is the channel capacity and that is equal to 1 minus, this is the binary entropy function. Okay, so the capacity is equal to 1 minus entropy. That is the simple relation. Now this equation is very important while solving the numerical questions for your competitive examinations and all. You will require this equation. Okay, now we can draw a graph between the probability and the entropy function, and you will get a graph like this. This axis is corresponding to the capacity, and this corresponds to the probability. So when probability, this axis is corresponding to the, that is the x-axis corresponding to probability, and y-axis corresponding to the channel capacity C. So when probability is equal to 0, I'll write it here. When P equal to 0, the channel capacity is C equal to maximum, which is 1. We know that when P equal to 0, we have to substitute in this equation. Write down the equation here. C equal to 1 minus HBP. This is the equation in which you have to substitute P is equal to 0. When HB of P is taken, you will get this portion is 0. C equal to 1 you will be getting. Okay. So when P equal to 0, channel capacity is 1. That is one case. Then second case, when P equal to 1 by 2. What will be channel capacity? That is equal to 0. Okay. Then third case, when P equal to 1, that is here. When P equal to 1, you will get C is equal to 1. Okay. That is when probability is 1, you will again get channel capacity to be 1. So this is the relation, and the graph will look like this. When you draw between the capacity and the probability, that is a crossover probability. When P equal to 0, C is 1. When P equal to 1 by 2, capacity is minimum or it is 0. When P is equal to 1, again channel capacity is 1. Okay. This is the relation, and this is the graph looking like. Okay. So this is how you can derive a relation between capacity and entropy, or this is the equation for the channel capacity of a binary symmetric channel. Now we will be doing some numerical questions towards the end of this video, but next we are going to discuss about binary erasure channel. So we have discussed about binary symmetric channel. Next we are going to see about binary erasure channel. So this is one of the very commonly used models in information theory and coding. So it is actually a very secure model. So if one symbol is received as an error, then the receiver will actually discard this symbol and will request for a resend from the source. So while designing the channel model, they have also included a symbol called error also. So in the previous model, we cannot find such a symbol. There is only 2 input symbols and 2 output symbols. There is no such a symbol called error symbol, or receiving of an error condition is not included in the channel model. But here, this is called BE, which is receiving of an error symbol. That is also included in the channel model. So this is A1 and A2 are the source symbols or the transmitter side. Then B1 and B2 is the receiver side or the receiving, that is the favorable conditions. But B is the error symbol or error condition. The probability of receiving of error if A1 is sent and A2 is sent is taken as P. Okay. So these 2 probabilities will take as P, and the probability of receiving B1 when A1 is sent is 1 minus P, and also probability of receiving B2 while sending A2 is again 1 minus P. So this is the model of a binary erasure channel. And if you draw the channel matrix, it will look like this. That is, we are simply writing a matrix with A1, A2, B1, B2, B1, BE, B2. That is a probability of receiving B1 when A1 is sent, BE when A1 is sent, B2 when A1 is sent. Similarly, B1 when A2 is sent, BE when A2 is sent, and B2 when A2 is sent. And this will constitute the channel matrix. So this is a P of B by A matrix. And if you write the channel capacity of a binary erasure channel, again, it is a maximum of information. And you can write C equal to entropy of A minus H of B by A. That is a conditional entropy. This is again an equation for the channel capacity. And what will be H of B by A? Sigma B PB H of A by B. So this H of A by B will be HB of 1 by 2. This is the binary entropy function, and we'll have to substitute the probability as I've discussed in the previous topic, that is for binary symmetric channel. I've told that we have to substitute P equal to 1 by 2 while calculating the capacity equation. Here also we are doing the same thing. In order to calculate the capacity equation, we are substituting P to be 1 by 2. So here we are putting 1 by 2 and we'll be getting HB of 1 by 2. And that is nothing but P, because HB of 1 by 2 is 1. Okay, so you'll get P. That is H of B by A will get as P. Also, what is H of A? H of A equal to HB of, that is HB means here it is denoting, this B is denoting a binary entropy function. Okay, so that is HB of 1 by 2, that is again 1. So the sum total or the end equation is coming as capacity C is equal to 1 minus the crossover probability P. So this is the capacity equation for a binary erasure channel. And for a competitive examination point of view, you only require this much. Okay, so this is how you can discuss about a binary erasure channel and its capacity. So we have discussed in this video about binary symmetric channel, its diagram, channel diagram or channel model, its matrix and capacity. And also we have seen what is a binary erasure channel and its channel matrix and also the capacity equation. So if you are preparing for any competitive examination, I would suggest you to study at least study the end equation for the capacity, which is very important. Okay, now we are going to see some MCQ questions, which are previous year gate questions for binary symmetric channel and binary erasure channel. The first question is the capacity of a BSC or binary symmetric channel with crossover probability 0.5 is dash. It's a very simple question, but this is a gate question, okay, because many people won't be knowing the capacity equation. So capacity equation of binary symmetric channel, that's the first topic that we have discussed today. C equal to 1 minus HB of P. Now what is P? P is 0.5 or which is equal to 1 by 2, right? Substitute it here, 1 minus HB of 1 by 2. What is HB of 1 by 2? We have discussed that binary entropy function of 1 by 2 is 1 minus 1. HB of 1 by 2 is 1. So it is 0. Okay. So probability, if it is 0.5, channel capacity is 0. So that's why we have drawn the graph like this. When probability is 1 by 2, then the value of capacity C is equal to 0 when probability is 1 by 2. Okay. So this is the relation, and the answer for this question is option B. The second question is this. So there is a channel diagram given. From the figure itself, it is very clear this is a binary erasure channel. The question is find the capacity of binary erasure channel. So what is the equation for finding the capacity? C is equal to maximum of I of x comma y. And also you can write in terms of probability C equal to 1 minus P. So here all the probabilities are equal. We have to take the probabilities P 1 minus 0.5, that is equal to 0.5 or equal to 1 by 2 bits per second is the channel capacity. Okay, so channel capacity C is equal to 1 by 2 is the answer. Okay, so from the figure you should be knowing that this is a binary erasure channel. Even if this term is not given, that is, it is just asking what is the capacity of the given channel diagram or the channel, then you should be knowing that this is a binary erasure channel. Okay, so answer here is 1 by 2 bits per second. The third question is, a binary symmetric channel has the following parameters: P of x by y. The channel matrix is given x1, x2, that is 3 by 4, 1 by 4, 1 by 4 and 3 by 4. Then P of x1 is 2 by 3, P of x2 is 1 by 3. Okay, so from this we can draw the channel diagram. There is x1 here, x2 here, y1 and y2. We don't need actually this for the finding the channel capacity, but anyway we'll draw a channel diagram for just understanding. So the probability of receiving y1 when sending x1 is 3 by 4. The probability of receiving y2 when x1 is sent is 1 by 4. Then the probability of receiving y1 when x2 is sent is 1 by 4, and also the probability of receiving y2 when x2 is sent is again 3 by 4. So again this is a BSC. These two probabilities are same and these two probabilities are same. So it is a BSC, binary symmetric channel. Now what is the channel capacity? So in the earlier, while discussing the theory part, this was 1 minus P, and this was P. Here also and here also, this is 1 minus P, right? So what is P? P is 1 by 4. 1 minus P is 3 by 4, right? So in order to calculate the channel capacity, we require the equation for capacity. So we have obtained P equal to 1 by 4 and 1 minus P equal to 3 by 4. And the channel capacity equation C is equal to 1 minus HB of P. We have to calculate here HB of P. Since it is not 1 by 2, we have to calculate and find what is HB of P. That is the entropy function value we have to find. First we will find it. HB of P equal to P log 2 1 by P plus 1 minus P log 2 1 by 1 minus P. This is the equation. Okay, if the value of P is not 1 by 2, you have to calculate using this equation. If the value of P equal to 1 by 2 means it will be equal to 1 only. How it is coming is 1, I'll tell in the towards the end. Okay, so here you have to substitute. P is 1 by 4 log 2 1 by 4 is 4. Okay, plus 1 minus P is 3 by 4 log 2 1 by 1 minus P, that is 1 by 3 by 4, which is 4 by 3. Okay, so this is the equation for finding the binary entropy function, and this is the sum. And while solving, you will be getting the value as 0.8113. Okay, so the value of the entropy function, that is the binary entropy function, we have obtained as 0.8113. Now consider that here P equal to 1 by 2. In the first question we have done in this video, we have directly taken HB of P while putting P here 1 by 2 as the value has obtained as 1, right? So this value I will note it here. Okay, HB of P we have obtained as 0.8113. Now consider that here we are going to see how the HB of P is coming as 1 when P equal to 1 by 2. So I am going to substitute P equal to 1 by 2 in this equation. Okay, here it is 1 by 2, then 1 by 2 will be 2, 1 minus P again 1 by 2, 1 by 1 minus P again 2. Now what is log 2 of 2? It is 1. So 1 by 2 into 1 plus 1 by 2 into 1. So 1 by 2 plus 1 by 2, that is equal to 1. So that is how the probability that is how, not the probability, that is how the entropy function is coming is 1 when P equal to 1 by 2. So for P equal to 1 by 2, the binary entropy function value is 1. For all the other cases, you have to use this equation. Okay, that is the general equation I'll write. P log 2 1 by P plus 1 minus P log 2 1 by 1 minus P. And you have to substitute the values for P. Here it is 1 by 4 and 1 minus P, which is 3 by 4 here. Okay, and then you will be getting the value for binary entropy function. But if the probability value is 1 by 2, you don't have to go for the calculation. It will be, that is a binary entropy function value will be equal to 1 only. Okay, so I hope it is now more clear to you how the entropy calculation and everything is coming for a binary symmetric channel. Okay, now we'll substitute the value here. Now we have obtained 0.8113. So 1 minus 0.8113 equal to 0.1887 is the channel capacity for this given binary symmetric channel. So these type of questions also can come in the examination. That is, a channel matrix will be given to you and you will be asking what is the, you'll be asked what is the channel capacity. So in that case, you have to use this equation 1 minus HB of P. So you have to put the values for P and 1 minus P and expand this binary entropy function, and you have to calculate what is the binary entropy function value, and then you will be finding 1 minus that value and you will be getting the channel capacity. Okay, so these are the questions which I have included in this video, and I am hoping that you understood what is a binary symmetric channel, how the channel capacity is coming, how the equation is, and how the calculation of channel capacity is being done, and also what is a binary erasure channel, what is the channel diagram, and also the capacity equation. Okay, so if you found the video useful, please do give it a thumbs up and also share it with your friends, and if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.